Lesson 7, we're still on the exponents. You have to go and simplify these exponents, and now all sorts of things come into play. Everything just says simplify, simplify, simplify. What I'm testing here is what? Prime factors. And then root 2 is the root law that says it's 2 to the power of a half. Right? And then what are we going to do with it 2 to the power of a half? X times the exponent of 4x minus 2 with it. And if you can do that in one step, it's fine. So at the 8, we're going to have our 8 substituted with 2 to the power of 3, meaning it's going to become 2 to the 3x plus, excellent, not plus 1, both of them multiplied. This 2 to the power 1 minus x, nothing happens to it. And I see some of you tend to want to always break it down, break it down. You don't have to, okay? Because eventually you're going to make it all 1. So with the 2 to the power of half, it's going to become 2 to the power of 2x minus 1. And then if you want to, you can already add the top 2 together. But do you have to? Sooner or later. So alternative, alternative. Some people want to simplify the top first before they divide by the bottom. You don't have to. If you did, it's 3x minus x is 2x. And 3 plus 1 is 4. So that when I add it, and if you don't have that step, your sum isn't wrong. As long as at the end you get 2 to the exponent. Because now when we are dividing and the bases are the same, how come I don't factorize here? Because it's multiplication. Only if it's pluses of powers do you factorize. So I'm just adding and subtracting the exponent. So we've got 2x plus 4 minus 2x plus 1. Because the principle here is you add the exponents if they are timed, you subtract them if they're divided. So it's 2x minus plus 4 subtracted, so it's minus 2x plus 1. Giving me an answer of 2 to the power of 5, which is 32. And very often there's no more x's hanging around. But the answer could be 2 to the 5 plus x. And then you leave it 2 to the 5 plus x. That's it. Right. Let's go on to number 4c, which is all about the roots again. Very important if you have that rule that you've got the base of A staying the base of A, becoming m over n. So that's the rule. So when we go to the sum, we're going to have 27 in a cube root, making it 3. X to the power, then we use the rule. Base stays base. 6 divided by 3 is 2. But the 27 wasn't the base. 27 is cube rooted. For this one, we say square root of 81, which has always been 9. Then we take the rule that says base stays base. Exponent divided by the root size of 2 gives me negative 4th root of 256. If you knew it, I'm very impressed with you. Otherwise, just do it on the calculator. And what is that? Is it 6? I hear 6. 4th root. How do we do 4th root on a calculator? Go for that little one that says 4 there of 256. It's 4. There's x to the power of. Divide it again and you get a 2. So now we can add our like terms, and they give me 3 of them plus 9 of them minus 4 of them, because I only add the coefficients, and it gives me 8x to the power. So how many marks for such a question? 2. 1, 2, 3, 4. It's all about the root rules. You don't write 27 to the power 1 over 3. You know that the cube root of 27 is 3. The last one that you had for homework, we're going to take that exponent on the inside as well. Now, what about 81 then? Will I write 81 to the power of a quarter? How will I simplify that without a calculator? Because now I need to see what you're doing with this without a calculator. What would you do with 81?
Prime factor.
Prime factors are 3 to the power of 4. And then we do take the exponent times with a quarter. Are you with me here? Then the same with the k. It's going to be k to the power of negative 2 times 1 over 4. Basically what you're doing somewhere on a piece of paper is time the top, time the bottom. So it's negative 2 over 4 or negative a half for the answer. K to the half, nothing happened there. Then again with the 27 to the power of negative 1. What does 27 to the power of negative 1 mean? If you wanted to write it that way. Or let's go back to 27 is also 3 to the power of 3. If we say 3, it's also going to be multiplied with a negative 1. And the k is also multiplied to the negative 1. So it's variations on that. Somewhere also we taught you that 2 to the negative 1 can be written as, are you with me?
Yes.
So if it's at the bottom, can I not then say 2? So actually this was 27 to the power negative 1. Why don't I just take the 27 to the top then? Alternative, all the ways. Like you can't use it unless you know it. So that'll happen to 27. Then if you wanted to keep it 27 to the negative 1, you can take the 27 to the top and make it 27 to the positive 1. That's a way of doing it. Let's check this out. So it's going to be 3 to the power of 1. And at the bottom we've got 3 to the negative 3. K is going to be to the power of minus a half, plus a half is 0. And then the minus 1 becomes a plus 1 at the top so that you've got left 1. Do you need to show me that? If you just come to 1, it's fine. And then what about this? At some stage you're going to have the 3 coming to the top and becoming 3 to the positive 3, which I did when I said 27 to the negative 1 comes to the top is 27 anyway. So your answer's right. And then don't lose the k, which means I've got 3 to the power of 4, which is 81k again. So you could have done this on various ways. Testing for exponents, testing for prime factors, etc. And now we're going on to the surd forms. The last section before we get to exponential equations is working with surds. Surds, which are root forms, surds is the grander English word, but some people don't even know what a surd is, but those are root forms. Now normally, just after the previous lesson, you want to say 12 to the power of 1 over 2. Is that true? Yes, but where are you going with that? So sometimes, and you'll see them in the exam A, especially, they do ask 1 or 2 surd questions. And all they want to know is, can you work with a surd or a root yourself? So how will I be able to simplify root 12? They wanted to simplify to the prime numbers. Prime numbers and roots. Actually what you're doing is you're going back to grade 8 where you were told to do prime factors this way. Do you remember?
Yeah, the letter method.
So that 12 can be divided by 2, giving me 6. 2 goes into 6 3 times and 3 goes into 3 1. So you're not going to do it this way, but this is where it comes from. So basically that meant that root 12 can be written as inner square root 2 times 2, which is 2 squared, times 3. Those are the prime numbers, prime. And then because of the root, if you square it and square root it, what happened to that 2? Nothing. The square and the square root cancel out. It's actually the root rule again, 2 divided by 2. But if ever I say root 3 times root 3, what should you know? The answer is 1. Because it's actually first root 9, and then it'll be 3. So what is root a of m times root m? Because that you can't do on a calculator. Will just be m. It's actually m square in a square root, which is m. So whenever you've got a root a times a root a, it'll just be a. Are you with me? That's the basic principle here. So if something is squared and then square rooted, you've done nothing to it, so the 2 comes out. But what about the root 3? It'll stay as it was. Now take your calculator and punch in square root of 12. To punch in square root of 12, what does the question give you? 2 root 3. You just got a mark for punching in your calculator. 2 root 3 is the same as root 12. Okay, and what about root 75? But now I'm going to teach you how to crook very publicly, because now you know how to do it the long way, but you're just going to do it on the calculator. For root 75, please don't put in 4 root 75. I want to see that you can do it punching your calculator. So to get all the marks, you need to show me that you know that root 75 on your calculator is
5.
5 squared.
5. Okay, if you did it this way, you'd get 5 squared times 3 if you did the factors thing. Okay, but then this will be, how do I time this? How do I time this?
4 brackets.
20. 4 times 5 is 20. And root 3. It's like you are timing A and 4. Because you cannot time root 3 with 20. What is the answer? 20 root 3. It's like using a variable. So if I'm saying that in the same breath there, I'm saying 2 root 3 plus 20 root 3 is 22 root 3. What principle are you using? They are like terms, like, because of the root 3 being similar terms. So I'm adding the coefficients and giving me 22 root 3. That's what they're testing. Whether you can, it's going way back in your life, to be able to write prime factors, to be able to write it in its simplest surd form. Root 12 is not simple. 2 root 3. And where did you get it? Your calculator. And the same there. So mark for using your calculator. And then your answer, knowing here that you must multiply, and you don't multiply the 4 and the 3, it's root 3. It's like saying 4 times 5a is 20a. And when you add them, you treat it like it's a variable. It's the same principles that apply. And that's your answer. Now, check it out. Punch that whole thing as a whole in, and your calculator will give you this answer. If you only give me the answer, how many marks will you get? None. Because the sum will say don't use a calculator. So you've got to show me, yes, that you know how to do it. The calculator does it. So that's why I'm teaching you to do it bit by bit and show you everything I want to see, although you're using your calculator. Right. So for the next one, let's get into these exercises with roots. For the next one, I've got a bracket square. There's roots there. If you want to say it's 1 over 2, you're not wrong, but where are you going with this? Because you cannot time in the 2 because of the plus. There's all sorts of things that you kind of think you want to do. You cannot time it in because of the plus. So what do we do with a bracket with 2 terms that's been squared? We time it out twice. You write it out twice. And just to save me some time, I'm writing it out twice immediately. Then what do? FOIL from grade 9. So when we do FOIL, we've got 2 times 2 is 4. Then we've got the middle terms. It's going to give me a plus times a plus is a plus. Let's check out if you understood what I said here. How do we time 3 root 2 with 2? 6 root 2. Because you cannot time the root 2. It's like a variable. It's like not the same as the others. Then for the same for that thing, because it's also the same exact values, plus 2 times plus 3 is plus 6 root 2. And then for the last ones, remember what I just told you. 3 times 3 will be 9. And then root 2 times root 2. Remember? Root 2 times root 2 is 2. Root 4 times root 4 is 4. Root a times root a is a. So root 2 times root 2 will be 2. Now I won't be very unhappy if you don't show me this and immediately say that it's 18. But now I can actually see that you're knowing what to do with these surds, with these root forms. So we've got 18. And then can we add them all together?
Yes, ma'am.
No, definitely not, because they are like terms. So the like terms will be 22, and 6 plus 6 is 12 root So how can I check it? Because there's no variables. If this was variables, there was a root m and a what, you can't put it in the calculator, but you can put this in the calculator. As is, what it was, bracket, 2 plus 3, root 2, out of the bracket, close the bracket and square it. Because that's exactly what there is. And your answer on your calculator gives you this. Again, answer only, no marks. Because you need to show me how you work with surds, although you're using your calculator to help you. If you did put in the calculator 3 root 2 times 3 root 2, it would give you 18. Okay. So with number 3, a little bit different. Now there's a fraction. First of all, can I not cancel out the 27 and the 3? That's wrong in so many ways. Okay, but mainly, you can't cancel anything out over a plus or minus like always. How do I then treat these roots? You break them down into prime numbers. How do you do it? Calculator. So what is the square root of 48? 4 root 3. Agree? Punch it. What about root 3? Don't do anything to it. Just leave it there. And then root 27. And you've just got 2 marks for punching your calculator buttons. Then what? What am I testing what you can do with surds here? You can factorize. Or what else? They are like terms. Those are the 2 alternatives here. Like terms means 4 of them minus 1 of them is 3 of them. And now I can cancel out, and I'm very happy to say the answer is 1. Then, Budi wanted to say, let's factorize. Take out a common root 3. So what's left? 4 over 3 root 3. Happy? What can cancel out? The root 3's. And if I simplify and add first and then divide, it's still 3 divided by 3, which gives me 1 alternative. Okay, the last thing for today I want to show you is that whenever you got to an answer like this, and you should think a little bit about special angles. If you know your special angles, like for instance, the sin of 45 degrees. If you know it this way, and there are various ways of knowing it. If you know that sin is opposite of our hypotenuse, and you do sin 45 without a calculator, we always do it with a calculator. But please do it on the calculator and tell me what the calculator answer is. Your calculator answer is root 2 over 2. Why does your calculator do that? And I know it's that. Because you shouldn't have an irrational number in a denominator ever, and your calculator's been programmed to always do that. And that's what I'm going to teach you to do now. You will always rationalize the denominator. So irrational denominator must become rational. So it's just a little bit of a trick, and it's almost never asked anywhere specifically, but so that you know why it does it. So I know it's 1 over root 2, but the calculator says root 2 over 2. Who's right? They're both right. This one's better written because it doesn't have irrational root numbers underneath in the denominator. But how? The method is you take your number, your 6 over root 3, and you say, because that's an expression, right? Not an equation. So you can't do all sorts of stuff, left and right, because there is no left and right. You're going to say, times it with, how will you get rid of the root 3? How will you get rid of the root 3? Same principle. Root 3, if you time it with, if you time root 3 with what? The root falls away. With root 3 or with. But you can't just decide to put something in a sum. You can only do it legally. What can you time with so that the answer is still what it originally was? If you times it with 1. Because that's the identity element of multiplication. So if you times with root 3 over root 3, am I timing with 1? So does the identity stay the same? Happiness? So that's the technique. You're timing with purpose to let the root disappear. That root 3 times root 3 will give me 3 without the root. And at the top, Because now this is fraction times fraction, top time, bottom time, so it'll give me 6 root 3. I'm going to only be able to convince you if you do it on the calculator. Is this the answer though? Can simplify? How? That'll give me 2 root 3 because the 3 goes into the 6. But the principle of rationalization is you timing to get rid of the root. The whole thing about root 3 times root 3 will give me a 3. And that is how you rationalize it. So if you put in your calculator 6 over root 3 equal, immediately the calculator does that because it knows it must rationalize the denominators. So what do I do with this one? Another example.
Your hand does.
Time with? Just by accident, it's root 3 again, but not root 8. 8's okay. 8's at the top in a root, that's fine. Timing with? With 1.
Ah.
Root 3 over root 3.
Nice.
The effect is what I wanted. I don't care what happens at the top, as long as the bottom doesn't have
A root.
a root in it. And what's the bottom going to be? No more root. That was my purpose. At the top? Okay, will you look at what the calculator does there? It does something else. Now there's variations on this. One thing you can do is to know if the two root sizes are the same, you can make it 8 and 3 inside of the same root. In other words, 8 times 3 is 24. You're allowed to. Can I split it up again? Yes, you're allowed to. But then again with the root 24, shouldn't we be going for the simplest factors? And if you break it down, it'll give you 2 root 6. And that's why your answer on the calculator, if you put that in, would be this answer. Okay, but that's not what the sum is about. You're getting a mark, if I do ask this 1-2 mark question of rationalization, you time it with the same thing to get the root to fall away at the bottom. It's not gone, but there's no more roots. There are roots in the answer, but it's not in the denominator. Last example, what about something like this? Because there's one little technique I still have to show you. What do you think we're going to time with? Because we're going to time with 1. What do you think we're going to have to time with? Okay, if it's 1 minus root 3, what's going to happen here? This is FOIL, right? And if you do that, what's going to happen to this FOIL? 1 times 1 is?
1.
Root 3 times root 3 is positive 3. I'm ecstatic, no more root. But what happens in the middle? Don't forget it's FOIL. So this is minus, there's still a root. And this will be minus root 3, which gives me minus 2 root 3. Minus 2 root 3. Are you with me? So the root doesn't fall away. So I'd like you to go and just check what happens if I make this a plus. Then it'll be first and last, and the middle will fall away, no more roots. I want you to go try that for yourself, please, on your own, and we'll carry on there tomorrow.